Ah, hi, there you are. No. Anyway, all right. So I'm going to start out. We're talking about the muscular system and the stuff I went over yesterday. I wanted to add some. Whoops. Hang in there a little, buddy. Okay. I wanted to add some specific videos dealing with some of the moving parts and things that we talked about. And this is the first one. So what we're going to be talking about is the neuromuscular junction. And it was a little bit difficult for me to talk about it because I was looking at a picture, but it wasn't my picture. And I like to have my own picture up there so that I can show you exactly what I want you to know. So when we look at this neuromuscular junction, at the top here, we have an axon. And we had looked at a picture with multiple collaterals, multiple branches of the axon. I've just drawn one. And where the axon and the muscle cell meet is called the neuromuscular junction. Now, at the very tip of that axon, we have this expanded region right there that is called the synaptic knob. And so what happens is I have to try and watch my picture there. You have a nerve impulse come down that axon, and when it gets to the end, to that synaptic knob, it causes the release of a neurotransmitter substance. And what's really nice about muscles is it's always the same one. It's something called acetylcholine. And so the neurotransmitter substance is released into that little teeny tiny opening, which we call the synaptic cleft. And what happens is that acetylcholine bubbles across that tiny opening, that synaptic cleft, and it combines with receptors on the surface of the muscle, on the sarcolemma of the muscle cell. And when the acetylcholine combines with the receptor, what happens? We produce another nerve impulse that spreads across the surface of the muscle cell, of the sarcolemma of the muscle cell. Now, we had talked last time about these groups of three, and we had called a triad, and we had said it consisted of a T-tubule, a transverse tubule in the middle of two cisternae of the sarcoplasmic reticulum. And we said the sarcoplasmic reticulum, endoplasmic reticulum, but the sarcoplasmic reticulum of the muscle cell, it has a very specific job, which is to hold, release, and recover calcium ions. And so we said, what causes a muscle to contract? Thoughts, nerve impulses. You think, I'm going to flex. I'm going to show off my muscle. Yeah? So when you do that, you send a nerve impulse to those muscle cells, and that nerve impulse goes across the surface of the sarcolemma, and it enters into the transverse tubule. And what does it do? It causes it to release the calcium. The cisternae of the sarcoplasmic reticulum releases the calcium. And you know what happens then? The muscle contracts. And that's another story. So, all right. So at this point, we were getting ready to talk about the power stroke, right? We were getting ready to talk about the power stroke, and then we diverged just a little bit to talk about how there are multiple neurons controlling any given muscle. And so we had said that we have motor units, which are one, motor neuron plus all of those muscle cells that nerve controls. And we had looked at a picture of 11 muscle cells, and we saw that the one motor neuron that was present was communicating with 3 of them. And later on, we had talked about something called the all or none principle. And we said that muscle, that each of those muscle cells, when they are told to contract, they don't do it a half-ass way. Pardon my language, but no, they say, okay, you want me to contract, I'm gonna fully contract. So whenever any one muscle cell contracts, it fully contracts. Now, later on, I'm sort of getting ahead of myself, but what the heck, you've already heard it in an hour and 20-minute presentation. So we'd said that a graded contraction, one where you only partially contract the muscle, that's where you have only used some of the motor units. And we had said some muscles have more precise movements than others, like your eyes or your fingers versus your back or your buttocks or your, hamstrings, whatever, the big prime movers. They are not as precise in their movements as these others. And so we had said that the large prime movers have bigger motor units because their interest is force, getting that power to those big muscles. Whereas with your fingers or movements of your eyes, you want it to be very precise, but it isn't, your eye doesn't weigh that much. It doesn't require that much force. Okay, now let's see where we are. Kind of glancing ahead. I think we are ready to talk about the power stroke. So I'll be right back.